Thanks so much for joining me. We've got severe thunderstorm potential to talk about across the eastern Canadian prairies, in particular southeast Saskatchewan and southern Manitoba on Saturday and Sunday. Risk of large hail, damaging winds, even some tornado potential. Of course, also torrential rain and intense lightning with these storms. So let's get straight into what is causing it. Here on this map, we can see a map of the United States and southern Canada. This is Manitoba and Saskatchewan here. And in Western Canada, we can see this sort of upper low, upper trough moving eastward across sort of Western Canada, BC, Washington, moving east slowly through the weekend. This is going to be our big weather maker that's going to be associated with these storms here. So these upper troughs in this jet stream, you can see rounding the base of this upper trough and kind of blasting out across the prairies, can kind of enhance our severe weather environment in a number of ways. It can cause air to rise on the large scale in the atmosphere that makes thunderstorms more likely. It can induce these large scale wind circulations that can feed, moist, unstable air into the region. It can cause the stronger winds in the upper part of the atmosphere can help organize these storms and whatnot. So there's lots of ways in which this upper trough is going to be playing a role in this potential severe weather across the eastern prairies. There are three main ingredients that all thunderstorms anywhere in the world need to form. They are moisture, instability, and lift. Of course, moisture is simply just you have moisture in the atmosphere to cause clouds, and those clouds can grow into thunderstorms. One way that we measure moisture in the atmosphere is through the dew point temperature. That, of course, is the temperature at which you have to cool the air to reach saturation. And we have moisture streaming into the region. As of Friday evening, there's actually not too much moisture out there across southern Saskatchewan, somewhat more in southern Manitoba. But most of our moisture is still well to the south in the central United States. But on Saturday morning through the afternoon, we're seeing this plume of moisture rushing northward into southeastern Saskatchewan and kind of hitting the brakes there, stopping along a warm frontal zone, kind of pools in that area. So we're going to get some moisture streaming in, what storm chasers like to call just-in-time moisture for the storms. It's just showing up right at the last minute before the storm potential really takes off. We've got moisture, check. Instability. Well, we've got instability as well out there. It's actually really closely tied to moisture. If you think about what causes unstable air. Think about warm and moist air down in the lower part of the atmosphere and relatively cooler and drier air aloft. If you force that warm, moist air upwards into that cool, dry air mass, and you get it high enough in the atmosphere that it saturates and starts to condense into water droplets, it gives off latent heat, and that causes it to be warmer than its surroundings, and it can rise freely on its own due to positive buoyancy at that point. So you'll notice where our maximum instability here develops is associated with where we saw the most moisture. So we've got moisture, we've got instability here in southern Saskatchewan with that hot, humid air mass streaming into southeast Saskatchewan. On this map, we're actually looking at a product called convective available potential energy, or CAPE, in joules per kilogram. Of course, we don't have thunderstorms everywhere we have CAPE. It's just if you do get a thunderstorm, it's a measure of that potential updraft strength. And so going back to the dew point map here, we've got moisture for Sunday's storms in southern Saskatchewan. We've got another plume of moisture, even deeper, richer moisture moving north into southern Manitoba for Sunday afternoon. So this could play a role in enhancing that severe threat in southern Manitoba for Sunday as well. And of course, if we look at our instability, you can see very unstable air streaming into southern Manitoba as well as we get into Sunday afternoon and evening. So check, we've got moisture, we've got instability. Do we have lift? Now let's take a look at a map of temperature and atmospheric or mean sea level pressure. And these these solid lines here are mean sea level pressure. They're isobars. So we can see basically this kind of circular area here in extreme northern Wyoming and southeastern Montana is what we call an area of low pressure. This is a surface low here. You can see these darker reds. Those are hotter temperatures. These wind barbs, if you can see them, are coming out of the south-southeast, bringing that hot, humid air northward. You'll see these kind of lighter reds and oranges here. These are cooler temperatures, and you'll notice those wind barbs are coming out of the east or northeast. Well, what you're seeing here is sort of the visual representation of a warm front coming off that surface low here, arcing northeastward across southeast Saskatchewan, getting into southwestern Manitoba there. What happens when this air converges along this boundary? You can get lift that forces that warm, humid air upwards, and you can get these thunderstorms to develop as a result of that. And as we get into Sunday as well, we still have sort of a big trough of low pressure from central northern Saskatchewan, western Manitoba down through the Dakotas and into northern Nebraska. So we've still got air coming together, converging together, such that we have the potential for lift in the atmosphere. So we've got our moisture, instability, and lift. There's one more ingredient that can sort of really help increase our severe weather potential, and that's called wind shear. That's when winds change with speed and direction with height, and there's other ways that we can look at that. We'll take a look in just a moment. This map here is showing simulated reflectivity, sort of coarse future radar, if you will, through Saturday. Now we can see there's some early scattered showers moving through the region, but our first storms really start to take off there, just where we would expect. We were talking about that warm frontal zone where that moisture is pooling, the instability is there, and the air is coming together. Bam, sometime between 3 and 6 o'clock, we got thunderstorms firing somewhere east of Regina in this environment. Those storms really blowing up through southeast Saskatchewan, western Manitoba, down into the northern states, into the overnight. And notice this big blob of heavy rain, thunderstorm activity that really starts to kick off, especially sort of between 9 p.m., around midnight, and even into like 3 a.m. There's lots of different ways you can force air upwards in the atmosphere. We talked about the warm front. There's other ways. One way is we've got this very strong wind that's forming in the lower part of the atmosphere in response to this low pressure system that develops. So through the day Saturday, we can see what's called a low-level jet stream. This is up just a few hundred meters off the deck here. And that air is flowing northwards. As we get into the evening, as we transition from evening into night, this can really ramp up in strength. And so what will happen there is you're pushing a ton of air into that front, into that warm front. But north of the front, it's kind of sloping upwards so that when you force that air up the slope of the front, it eventually can start to rise on its own due to positive buoyancy. So we're getting a lot of thunderstorms likely supported by this mechanism of this sort of low-level jet stream intersecting with that frontal zone and causing thunderstorms really to erupt across southeast Saskatchewan, southwest Manitoba. Those storms, there may be some severe threat with those, but they're likely going to be largely heavy rain and perhaps some intense lightning there through southeast Saskatchewan and southwestern Manitoba into Sunday. So that will play a role. Also continuing to see that low-level jet stream in southern Manitoba Sunday, and that could help increase our potential for tornadoes in southern Manitoba as well on Sunday. Let's actually break down a little bit more about the specifics of the environment. Weather forecasters, meteorologists have lots of tools at their disposal for kind of assessing what type of threats might be associated, because you might have a thunderstorm environment. Great, you got your moisture, your instability, your lift, you got your shear, but it's not the same. There's so many different ways those can manifest themselves. So that'll determine what your threats are, your primary threats. Are you looking at more of a hail and wind threat? Or are you looking at more of a tornado potential? So, this is one of the ways we can do it. So if we look at this map here and we click on the map, we can actually go and assess. Now, what's going to pop up here is a couple of diagrams. They may seem a little bit overwhelming at first, but I'll try to make it simple and I'll break it down here. On the left-hand side here, we're seeing what's called a Skew-T diagram. Skew-T because it's temperature along the bottom, and the lines of temperature here are skewed up and to the right here. They're slanted up and to the right. This diagram, you can really assess what the stability profile is in the atmosphere. The red line is your temperature with height throughout the atmosphere, and the green line is your dew point. We'll come back to this in a second. On the right, this is your hodograph. This shows how winds change with speed and direction with height, and it's just basically a measure of wind shear, and can help you get a sense for what sort of threats might be associated with your storms, how they may organize. So again, coming back to the left side here, so at that spot on the map that I clicked, we can see in southeastern Saskatchewan at 6 p.m. local time, the temperature here on this weather model is just about 30 degrees with a dew point of 18. So it's pretty humid, but there's still a little bit of dryness down there in the lower part of the atmosphere. So just a quick kind of crash course on how to use this Skew-T. Picture you have an invisible parcel of air, like a balloon of air. We'll just collect a random meter cubed of air down in the lower part of the atmosphere, and it's got this temperature and this moisture content. You force that parcel of air upwards, it's going to cool off to the point that it saturates. It starts to condense out all the water vapor into water droplets like we were talking about before. It starts to give off heat to its surroundings, and this parcel of air finds itself warmer now than its surroundings because it's giving off heat, the latent heat of condensation. So now it's starting to rise freely on its own. And as it goes upwards, this is our theoretical parcel. Our balloon is going to follow this blue dotted line. And anywhere that it's to the right of the red line. That means it's warmer than the environmental temperature. This parcel of this balloon of air that we've forced upwards is warmer than its surroundings. It's less dense. It rises freely on its own. And through a deep layer of the atmosphere, it can really start to get some momentum and start shooting upwards. This makes up what we call our updraft of the thunderstorm. And you just basically picture like trying to force a soccer ball to the bottom of a swimming pool and then releasing it. Inside the ball, you've got all that air. It's a lot less dense than the surrounding water, so it shoots upwards. But eventually, you run out of, you've condensed all that water out of it, and it stops giving off that heat, and it reaches the same temperature as its surroundings again. But it's got momentum, so it tends to go a little bit higher. If you've ever seen a thunderstorm cloud in the distance, it's got that big anvil. You can see a little bit of a dome part that rises a little bit higher than the thunderstorm itself. That's what we call the overshooting top. That's literally the visual manifestation of that updraft, having momentum and just punching upwards. Call it an overshooting top. And so, yeah, this, again, so with this, you can, let's just look at it for a second here at about 6 kilometers, say. We'll go from 6 kilometers over here, intersect the temperature line, and we can see, if we follow it back down, the temperature at 6 kilometers above the ground is about minus 19, a little chilly up there. But over at our blue line here, you come back down to the ground, it's about minus 9. So it's like 10 degrees warmer. Our parcel of air is 10 degrees warmer. So you can see just how much warmer it is than its surroundings. It's going to go upward on its own due to its, it's less dense. It's warm. It's got its own positive buoyancy. And so we were looking at the map with CAPE. This area here between this blue dotted line and the red line here is your visual manifestation of the CAPE there. That's we can calculate this area here. That's 3,563 joules per kilogram. That's this area right here on this Skew-T diagram. So, what can a strong updraft do? Well, one of the things it can do in a certain environment, if it's in the right type of wind shear environment as well, is it can support the development of large hail. This type of CAPE can create an updraft like 30, 40 meters per second. That's a strong wind blowing straight upwards. It can help these large hailstones levitate and grow in the thunderstorm updraft. So yeah, large hail might be a potential with this sounding. And we can go down and look here in the bottom. We've got the analog system here when it compares to other past environments and saying, have we had severe hail with this type of environment in the past? Yes, we've had several instances of baseball or larger size hail with this type of environment. Okay. So, a weather forecaster might quickly look at this and say, well, this looks like potentially a large hail environment. What about strong winds? Yep. Well, let's look down at the opposite here, this purple dotted line here. What's happening is you start to get that updraft. It's going upwards. It's creating precipitation particles, rain and hail. They start to collect in the upper part of the cloud, and then they start to fall down, and they pull air down with it. Precipitation drag starts to drag the air downwards. As it's moving downward, that becomes your downdraft. And it can actually entrain air or suck air in from outside of that thunderstorm and mix in drier air. And of course, we've got that dry air beneath the base of the thunderstorm as well. And that causes evaporative cooling. It's the opposite process. As you evaporate those water droplets, it removes heat from the surrounding environment, and that air becomes negatively buoyant, colder and denser than its surroundings, and it drops just freely like a rock near the ground here. You're much colder. So, say you're near 30 degrees at the surface here. By the time that downdraft hits the ground in this environment, we're seeing about a 13 degree, like a chilly cold wind when it hits the ground. And when you have that much negative buoyancy, again, you can see it on this here, it's 1,333 joules per kilogram. That's your downdraft CAPE, negative CAPE. So it's going downwards. And this cold air hits the ground and spreads outward. It's like turning on a tap in your sink, and it spreads outward along the bottom. That's like when a cold downdraft hits the ground, spreads out in all directions. You can get damaging winds with that. Like you only need like 750 or 1,000 D-CAPE to get damaging winds, 90 kilometers an hour plus. Again, oversimplifying somewhat, but in general, when you have large D-CAPE values like this, damaging winds could be a threat as well. So large hail, damaging winds. Already looking at this one here. On the right, we're looking, weather forecasters, folks who've spent a long time looking at these photographs and looked at thousands of them, they can start to kind of assess based on the shape of this photograph. This looks like more of a hail threat. This looks more like a hail and tornado threat, or this looks primarily like a tornado threat. This one in particular looks more of a hail threat to me, but there is some low-level wind shear down here that could support tornado potential. But again, this sounding and photograph kind of combination here does seem to support more large hail and damaging winds. But when we get into a very specific zone of southeastern Saskatchewan, that warm frontal zone we were talking about. There can be this enhanced wind shear in the low levels along a very narrow zone, a narrow corridor. And where the air converges together, it can actually cause these little swirlies of air that if they get sucked up into the base of the thunderstorm, they can increase tornado potential that way too. So there may be a focused narrow zone of tornado potential in southeastern Saskatchewan tomorrow along that warm front, somewhere east of Regina, perhaps along the Trans-Canada Highway, somewhere south of Yorkton, north of Estevan, and out toward the Manitoba border. So we're going to want to watch out in that area. All hazards possible with these thunderstorms. Elsewhere, if storms initiate, likely just a large hail and damaging wind threat. If we move into Sunday, and we'll actually take a look at what happens in southern Manitoba. Again, just pointing at this is one weather model and one spot on the map, but just to get a kind of very basic sense of what might be happening here in this environment. This looks a little bit more potent than Saturday. We've got larger CAPE here, and we've got stronger wind shear in the low levels here. And so right off the bat, this looks like large hail, damaging winds as well, very large D-CAPE as well. So again, we've still got that potential for strong downdrafts, what we call downbursts, but we've also got much stronger wind shear. So if these storms, they're initially what we call discrete, or they're isolated storms, and they don't have a really progressive outflow coming out of them from that really strong downdraft, they could have tornado potential as well. When you look at this trace here, basically you just put yourself at the center here, and these are the winds through the atmosphere. So again, like this is a southeast wind at your back. At the surface, this is just a cranking 20 knot southeasterly wind here in southern Manitoba at this location. That's almost double that as your kilometers an hour. It's probably like 38 or something, 38 kilometers an hour. It's ripping. 1 kilometer off the ground, you're already over 40 knots out of the southeast. 3 kilometers off the ground, you're over 40 knots out of the southwest. There's your speed and directional wind shear. What this can do in the lower atmosphere is cause this horizontal rotation that can get ingested into a thunderstorm updraft, tilted into the vertical, and can cause that vertical rotation. So again, that can increase your storm hazards, your large hail potential, your tornado potential with these storms. Again, like I say, we've got some serious hail analogs with this sounding 6-inch hail analog at the top, CD sized hail. Again, this is certainly not a guarantee we're going to be seeing that in southern Manitoba, but your alarm bells are going off here. Okay, this is a potent environment. It's supportive of large hail, damaging winds, and potentially tornadoes. So we're going to have to watch how that sets up, though. So let's actually take a look at how it might progress. This is just a single model and a single run of a single model, but just to get a sense of what may actually pan out as we get into Saturday afternoon. Looks like we've got some thunderstorm activity early on in the day that might kind of reinforce the cooler side north of the warm front. But you can clearly see on this model that warm front taking shape in the afternoon, and boom, storms erupting along that front somewhere 6, 7 o'clock local time. I think it could be a little earlier and a little further north as well here. But these thunderstorms, again, as we spoke of, large hail, damaging winds, the main threats, and potentially some isolated tornado potential in that narrow corridor along the warm front. Storms erupting throughout the evening and overnight hours across southeast Saskatchewan, southwestern Manitoba, bringing mainly heavy rains, maybe some severe potential in there as well. But as we get into Sunday, there's still some lingering thunderstorm activity throughout parts of the prairies. This might actually serve to reduce our severe potential. So it's somewhat conditional upon whether, we still have all this lingering cloud debris and precipitation. If this is hanging around, it'll actually make our environment less potent. It'll make it cooler in the lower part of the atmosphere. That reduces our instability and makes our potential updraft strength that much weaker, so that our severe hazards overall would be less. But we do still have this really strong push of moist, unstable air streaming in from the south. If we clear out, if it gets sunny and hot on Saturday or Sunday afternoon, rather, in southern Manitoba, watch out. We could be seeing the potential for severe thunderstorms with all threats. This cold front starts to really push into the region into the afternoon and evening. These storms initially may start out isolated or discrete, and that's when they're going to have their greatest threats for hail and tornado potential before they potentially grow upscale. Basically, they all just join arms and march across the landscape as a big linear thunderstorm system. And it just charges across southern Manitoba on this model through Sunday evening. So Winnipeg, watch out. Red River Valley here, mid to late evening, big thunderstorm system coming through, large, likely mostly strong wind gusts, torrential rain, intense lightning, based on this model anyways. Looks like most of our High-end severe threat is going to be further to the west. So Brandon, perhaps Portage la Prairie, anywhere in southwestern Manitoba here or far southeastern Saskatchewan, we're going to want to watch out for on Sunday evening. So there you have it. Looks like we've got some severe weather potential in the prairies, eastern prairies in particular. So stay weather aware, have a severe weather safety plan, and stay tuned to watches and warnings for the latest. And thanks so much for joining me. We'll talk to you next time.